Hi, today we're going to look at logarithmic graphs. Slightly complicated because we've got this 1/2 and we've got this x minus 3 in here. So I want to look at the basic form of this graph, or sort of in a way we call it the parent function of the graph. And that's just going to be log base 4 of x. We'll worry about 1/2, we'll worry about 3 later. So what's my base? B equals 4. We're going to continue starting this off like we would any kind of more simplified version of this. We have our 3 coordinates. Let's take this 4, drop it in its 2 places, and we're going to say 4 comma 1 and then 1 over 4. Now I want to take this and graph what's called, I guess, the parent function of this, and then we're going to shift that whole thing. So we're going to go over 1/4, we're going to go down 1. We're going to go over 1 up 0, and we're going to go over 4 and up 1. And I'm going to draw this real lightly because this will change. Okay, now we're going to bring in the 1/2, we're going to bring in that 3. And we bring them in the matter of order of operations. So we have to take care of any multiplication division first before adding and subtracting. That's this before we do that. So we're going to worry about the 1/2, we're going to worry about the 3. Now, why do we got to worry about them? What are they actually going to do? If we go backwards to quadratics and you had vertex form and you had these shifting of these graphs, you'll find out that this formula, the basic form of log, is very similar. The k at the end takes our graph, shifts it up and down. The h on the inside shifts this thing left and right in the opposite direction. The a tells us a couple things. We can get wide or thin. And if there's a negative upside in front of it, it tells us to flip that whole graph. Okay, so what does that mean over here? Well, this 3 says we're going to shift it 3 spots to the right. Okay, this 1/2 says we're either going to get really wide or we're going to get really, I guess, wide or thin. In this case, I could kind of change that wide and thin to maybe like tall and flat. So let's switch those words. We'll say tall, flat. Okay, let's take care of that 1/2. What I want to do is take my y values and multiply them by 1/2. So if I'm at 1, multiplied by 1/2, I'm right there. Take 0, multiplied by 1/2, nothing changes, still there. Take -1 multiplied by 1/2, all of a sudden we move up a little bit. Okay, that's the 1/2. Now we're looking at the 3, and we're going to shift this whole graph 3 units to the right. Every one of these orange coordinates, we're going to move to the right 3 spots. So we're now going to go like that. 1, 2, 3. 1, 2, 3. And 1, 2, 3. I know this is kind of funny looking, but there you go. So what's happening with this graph? Moving to the right, moving upwards very slowly, but it's always going up. Down here, we're always going to go down very quickly, and this line is never going to go past this x equals 3. So normally, green dashed line, we're never going to hit x equals 0. We have an asymptote there. Here, we now shifted that thing over 3 spots, so our new asymptote is at x equals 3. And that's graphing logarithmics graphs.